right, we're going to look at renal system models. So we use this three-part model, look at the big one, then we'll look at the zoom-in sections. So if you look at this section, kidney, for kind of the gross anatomy here, this outer layer right here between the pointer and my finger, this is the outer layer of the kidney. It's referred to as the cortex. So all this is cortex. The inner layer, it's called the medulla, and what you'll note, it's made up of these kind of darker stained triangular blocks. These are called renal pyramids. So the layer is the medulla. These specific blocks of tissue are the renal pyramids. And do notice there's pieces of cortical tissue that dip down between the pyramids, right here, right here, right here. These are called renal columns. Here, here, a little bit here, a little bit here. The apex of the pyramid, this little pointy bit here, there's one here, one here, one here. These are called renal papillae, just kind of, again, the apex of the pyramid. And note that they project into this hollow space here. There are openings in these renal papillae. These are where the collecting ducts drain out, and they'll fill this space here with urine. So this space in front of each papilla, these are minor calyces, minor calyx, minor calyx, minor calyx, minor calyx. They flow into a bigger area called a major calyx, and from there the urine will drain out into this funnel-shaped piece called the renal pelvis, which drains into the ureter. The other part on this model you might want to take a look at is the vasculature, the blood vessels. We've already looked at the renal artery and vein here and here. If we follow the renal artery in, it will split into these smaller branches called segmental arteries that then split into these smaller branches going up between the pyramids. These are the interlobar arteries that arc around the back of the pyramid here and here. These are the arcuate arteries. And then radiating out into the cortex off the arcuate arteries, these are the interlobular arteries or cortical radiate arteries. A couple names, same thing. And now if we switch to this enlargement here, this is one renal pyramid with its overlying cortex. Here's the papillae. If you look at the vasculature here, this is the interlobar, this is the arcuate artery, and this is one of those interlobular or cortical radiate arteries. And then you can see the arterioles on this one. These little branches coming off of the cortical radiate artery, those are the afferent arterioles that go into this glomerulus, and then are drained by the efferent arterioles. You can see it on this larger magnification as well. This is an afferent arteriole, goes into this glomerular capillary bed, and then it is drained by the efferent arteriole. Note that's a little odd. You have an arteriole supplying and draining a capillary bed. That's a little different. Usually a venule would be draining the capillary bed. That's afferent and efferent arteriole. Then the other part of this model you want to look at will be the nephron, the kidney tubule. All this light stained material is nephron, and this is a much larger enlargement part of it. We'll start at this little spherical shaped structure here. This is the Bowman's capsule. It's actually a double-walled cup. It's a little hard to see on this magnification, so I'll go over here. There's this outer parietal layer of the Bowman's capsule that folds back on itself, and this yellow here, these are the fine layers of the visceral Bowman's capsule that are actually wrapped around the glomerular capillaries. On this model, they're showing you the visceral layer of the Bowman's capsule on this side. Over here, they've stripped it away just to show the glomerular capillaries. Normally, these would be covering all of these capillaries. After the Bowman's capsule, this little twisted up piece right here, closest to the Bowman's capsule, that is a proximal convoluted tubule, which they may then lead into this long loop of Henle. Some of them are shorter. The loop of Henle then comes back up to the cortex, and this is the distal convoluted tubule. And the distal convoluted tubule will drain into this bigger collecting duct. Multiple nephrons will drain into this one collecting duct on this model. See, all these would be inputs here, 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 here. That's a collecting duct that will drain the urine out into the minor calyx, which would be down here. The only other thing I should mention on this one, you got the Bowman's capsule. This is actually part of the proximal convoluted tubule. This is part of the distal convoluted tubule. It actually twists around and comes back behind it. In this area highlighted by kind of that red square there, that is the juxtaglomerular apparatus. It's where the distal convoluted tubule, the afferent and the efferent arteriole kind of bump into each other here. There's a collection of cells there that do things like monitor blood pressure and concentration of filtrate in the nephron to help control blood pressure by releasing renin that has an impact on blood pressure. I think that's all we need for the model.